solving a 3 by 3 linear system. We first begin with the linear system, something that looks like this, and the question is asking us to solve this system using the method of matrices. So what we're going to do first is write what is known as the associated coefficient matrix. So it's basically the matrix version of this system. And so what I have done is just wrote down the matrix where we collect each and every one of the coefficients, and then we just write them down in the correct order, where the left column is the x column, middle column is the y, the right column is the z, and then we have a separation, a little dotted line segment here, followed by the solutions column, which would be, in this case, -3, -3, and 16. The goal here, as with any matrix problem, is for us to ultimately turn this matrix into a matrix of the form 1, 0, 0 in the left column, some unknown value 1, 0 in the middle column, and then on the right column we have, let's just put stars to represent the unknown values. We have 2 unknown values followed by 1, and then on the right hand side we also have just constants. And so in this case, let's suppose we just call these constants S1, S2, and S3. So this is the goal, and obviously the most difficult part of these problems is to actually take the correct steps to get from here to here. So all of the work is done inside this dotted right arrow. And so we have 3 rules that we could follow. One rule, what we could do is swap any 2 rows. So we can take any 2 rows and swap them. 2, we can multiply any row by a non-zero constant. By a non-zero constant, we're going to write SC is not equal to 0. And then 3, we could add any row to another row. Now, in practice, what we do a lot is we actually combine the second and third rules together simultaneously. So a lot of times what we would do, for example, is we could take a row, multiply it by 2, and then take whatever that result is and add it to another row. As opposed to just adding a row to another row, we can, again, multiply a row by a number and add to another row. So we'll definitely see that in this example. Let's first begin by taking this original matrix. We want to organize this into this format. And so the general approach is we're going to take this left column first. Looking at this left column, we need to somehow make this into 1, 0, 0. First thing we see is there's a 1 here. Now, this 1, if we were to move this 1 to the top upper left corner, then it would take care of this 1 over here. And the simple thing for us to do is just swap row 1 and row 2. In fact, what that'll do is that'll also get us a 0 in this middle left position. So let's say we're going to do that, and the way we will show our work is we're going to write R1 double arrow R2 to represent that row 1 and row 2 are getting swapped. And so what we have is 1, 6, 1, -3, 0, 2, -1, -3, and then the bottom row doesn't change, so we have 4, -1, 7, 16. Okay, so what we'll try to do is we'll do a little bit of a zigzag here to move around, but we'll definitely label every step with an arrow telling us which matrix we're going to. Okay, so first we now have the 1 and the 0 in the correct places, and then the next thing we want to tackle is this 4. This 4 is supposed to be a 0 right over here. In order for us to take this 4 and turn it into a 0, we can only use the 3 rules, and what we want to do in this case is use the rule that says that we can multiply by any row. Let's say we multiply this top row by -4. if we were to multiply this top row by -4 and then we add, which would be a third rule, add that result to this bottom, then in effect what we would have done is taken this 1, multiplied it by -4, added it down here, and then turn it into a 0. But as with that, there would be a chain reaction of the same thing happening for all the different entries. The way we're going to show that is we'll write it as row 3 is equal to the previous row 3, we'll use lowercase r, minus 4 times row 1. So the idea here is anytime when we use a lowercase r, it means from the previous matrix. Anytime when we use a capital R, it's from the new matrix. So let's say we have, we'll set it up. What's happening here is that the row 3 is changing, which means that row 1 and row 2 are not. We're just going to copy those down real quick. 1, 6, 1, -3, 0, 2, -1, -3. And now what we have to do is we have to be a little bit careful here. We have to take each of these entries, multiply by -4, add to the bottom. So 1 times -4 gives us -4. Add to the 4, we get 0. 6 times -4 gives us -24. Add to the -1, we get -25. 1 times -4 gives us -4. Add to the 7, we get 3. -3 times -4 gives us +12. +12 added down here will give us 28. So this allows us to finish the first column. We now have 1, 0, 0. Now the next thing for us to tackle, this is going to be a little bit more tricky, is I want to turn this 2 into a 1, but to turn this 2 into a 1 would potentially require us to either multiply through by a fraction to turn into a 1, or we could use another row to do it. Instead, I want to take the following step, which may seem a little bit roundabout, but in the long run it'll turn out to be a little bit cleaner. I want to take this middle row and multiply by 13. So row 2 equals 13 previous row 2. So that means we have row 1 staying the same, row 3 staying the same, but then row 2 is going to change because we're multiplying every entry in row 2 by 13. So 0 times 13, 0. 2 times 13 gives us 26. -1 times 13 gives us -13. -3 times 13 gives us -39. The reason why I wanted to multiply by 13 is because I really wanted the 2 to turn into a 26. This is good. The 26 is good for us because we see that this bottom entry here is a -25. So the next immediate step we're going to take is just take this bottom row and add to the middle row. And so that this -25 will drop the 26 down to a 1. So let's actually zigzag back the other way. So we now have row 2 is equal to row 2 plus row 3. And so let's write that down. We have 1, 6, 1, -3. The bottom row is 0, -25, 3, 28. And now we're going to take bottom row, add to middle row. 0 plus 0, 0. Bottom row, add to middle row, -25, add to 26, we get 1. 3 added to the -13, we get -10. And then we have 28 added to the -39, we get -11. So we're almost there. We now want to take this middle column. We have a 1, which is good. That's the 1. But now we also need a 0 on the bottom. So we need to turn this -25 into a 0. On turning this -25 into a 0, the only thing we can do is take this middle row, multiply it by 25, and then add it down to the bottom row. So we're going to write it up here. R3 equals old R3 plus 25 times R2. And so let's copy that down. That means row 1 and row 2 are not going to change. So we have R1 being 1, 6, 1, -3. R2 is 0, 1, -10, -11. and then the bottom row, row 3, is going to change. We're going to multiply 25 times the middle row, add to the bottom row. So 25 times 0 plus 0, 0. 25 times 1 is 25, add to negative 25, 0. Multiplying this, and this gets a little tricky, we're going to multiply the negative 10 by 25. That gives us negative 250, which is a large number, but it's negative 250. Add to the 3, we get negative 247. And now we want to multiply the 25 by the negative 11. So let's do a quick computation on the side. We have 25, 0, 5, 2, 275. So 275, so we have negative 11 times 25 is negative 275. Okay, we're going to put a negative there. But then I want to add it to the 28. Okay, so let's see, what is that? So we have 275 minus 28. When we subtract, we have 7, let's see, 4, 2. So we have negative 247 again. Now this is a very good thing for us. We see that this bottom row, we have 0, 0, negative 247, negative 247, and so that tells us we are pretty much done. One last step to modify this bottom row. And keep in mind, so this middle column is done. We have some number times 1, some number 1 and 0. We have 6, 1, and 0. The right column, we got a number, and 1. We have a number, and negative 247. So we need to turn this negative 247 into a 1, and the way we're going to do that is just to divide by negative 247. So we're going to take this bottom row, row 3, and we're going to divide by negative 247, and we will express that as negative 1 over 247, row 3. So this is the way we're going to label multiplication by negative 1 over 247. And so what that gets us, we're going to run out of space a little bit, but let's try to fit it in there. Where it'll get us is the top row is 1, 6, 1, negative 3. Middle row 0, 1, negative 10, negative 11. And the bottom row is going to give us 0, 0, 1, and also 1, because when you take the negative 247 and multiply by this, we get 1, and the same thing for this lower right corner. And so here's our goal. We have achieved our goal. This is 1, 6, 1, negative 3, 0, 1, negative 10, negative 11, and 0, 0, 1, and 1. Now at this point, what we could do is revert back to the original variables. We want to convert this back into a system. And so to do that, let me adjust a little bit. So to do that, we can convert this back to x plus 6y plus z is equal to negative 3. The second equation is now y minus 10z is equal to negative 11. And then the bottom row we have 1 and 1, which means z is equal to 1. The whole purpose of having this structure right here, where you have 1, 0, 0, some number, 1, and 0, some number, and 1, is so that when we convert back, you end up with some sort of diagonal sort of configuration. This is good for us because in order for us to solve, first of all, we already know what z is. In order for us to solve for y, we're going to take the z, plug it into the middle of the equation, we're going to solve for the y. So that means we're going to get z, and we're also going to know what y is. And then from there, we can take what we already know from y and z, plug it back into the top equation, and then we're going to get x. And so that's going to be the general way for us to solve this system. Now this exercise right here is primarily to talk about how to convert the original matrix into ultimately this special structure matrix. So I will leave the problem up to here for you to complete. So that's it. Thank you.